Assalamu alaikum students. Let us start the new topic of chapter number 16 named as the semiconductors. From its name it is very clear that the materials that allow some of the electricity to pass through it and do not allow some of electricity to pass through it are called semiconductors. Now from its name let us write it's very clear that it passes some electricity and it blocks some of electricity. These type of materials belong from group number 4. So let us write group number 4, and that materials are mainly the germanium and silicon. These germanium and silicons are the pure type of semiconductors because they have the 4 electrons in their valence shell. That's why they allow some of the electricity to pass through it and doesn't allow some of the electricity to pass. Now in it, what is the capability in that group is that only few electrons could jump from valence band to conduction band. Now as we know that when we recall our the old chapter, the part number 3 is that for the perfect transmission we need an electron to transmit from valence band to conduction band. Now when an electron easily transferred from valence band to conduction band, that is known as perfect transmission, and we need more number of electrons from valence band to conduction band to pass through it for the perfect transmission. So overall we say that there is small amount of electrical conductivity. Now to increase the little conductivity, we need some of the impurities to be added into these semiconductors materials. Like we sometimes we add group 3 and group 3 elements, sometimes we add group 5 elements into them. So now let us write. Now we have to increase the electrical conductivity of the semiconductors. So the question is raised is how to increase the electrical conductivity in semiconductors. Now the first idea is to increase the material's temperature. Now the first point is to increase the temperature of material, and the second point is a technique that is known as doping. Now doping is a technique by which we can add some impurities into the group 4 element. So we will write it is a technique by which we can add impurities into tetravalent group 4 elements. Now we have to increase the electrical conductivity. For increasing the electrical conductivity, we have two options. Number one option is to increase the temperature of the material, and number second option is doping. And we have now we are familiar with the doping. The doping is a technique by which we can add impurities into these tetravalent elements. So now what will be the impurities? The question is that. Now, the impurities may be of group 3 element or may be from group 5 element. In group 3 element, as we know that there are 3 valence electrons, and in group 5 elements we know that there are 5 valence electrons. When we add materials from group 3 and group 5, that semiconductors are known as extrinsic semiconductors. In extrinsic semiconductors, there are two types. Number one is N-type material, and the second one is P-type material. Now in N-type material, the majority of the carriers are electrons. So we will write the carriers the charge carriers in N-type material are electrons, and the charge carriers in P-type material are called holes. So it is very clear that to made an extrinsic semiconductor, we have to add the impurities from group 3 or group 4 elements, and by that we can get N-type materials and P-type material. And N-type materials are the materials in which the majority of the carriers are electrons, and P-type material are in which the majority of the carriers are holes. We were discussing about the techniques of doping. Now, as discussed, there are two types of doping. Number one is donor doping, and number two is acceptor doping. The donor doping is known as N-type doping. As we have discussed earlier, the donor doping is N-type doping, and acceptor doping is called as P-type doping. Now, in N-type, we know that when we have to make the N-type, we have to add group 5 elements into group 4. Means in pure semiconductors, we have to add the group 5 elements, and the group 5 elements may be arsenic or some other from group 5, and they may be added into silicon or germanium. To make the acceptor doping or P-type doping, we have to add the group 3 elements into group 5, oh sorry, group 4, and the group 3 elements may be indium, In means indium, and Ga means gallium. So when indium and gallium are added into the group 4 elements, that type of doping is known as p-type doping. And when arsenic or scandium are added to the group 4 element like silicon and germanium, that type of doping is n-type doping. And as discussed earlier, in n-type of doping, the majority of the charge carriers, so we'll write the majority of charge carriers are electrons, and in p-type the majority of the charge carriers are holes, and in n-type the majority of the charge carriers, let me write, these are electrons.